Hi, morning, everyone.
Good morning.
Yeah. Good. Okay. So we can start, right? Um, Let me try to share my screen. Give me one sec. Good for screen sharing. Okay. I think last lecture we talked about the packet queuing delay, right? Also, we talk about other delay. Still remember? We use a caravan example to let you know how usually packet switching or sending or receiving packet, right? Where is the delay? We have several delay, right? Usually we care about the transmission delay and the propagation delay, right? Because they have sometimes they have largely different in different cases or different links, right? And finally, we talk about after the example, we talk about um, if the we have some packet arrive rate and we have the packet length and we have the link bandwidth. We were talking about when the queue delay would be very large and sometimes would be small and sometimes it could be infinite, right? So you can think about when you don't understand the packet sending receiving delay, you can think about the traffic in the highway. Okay, so I think this is something not difficult to understand. And I think we also talk about how we can measure the delays through the routing or the links or transmission, right? Here is a program, or you can think about this a small benchmarking program, right? To let you know, provides you some idea, uh, the real delay from, for example, your laptop or desktop to the destination or the server or the IP address you want to access. Okay, so it will send, generally speaking, this program will send 3 packets that will reach router I on path towards the destination. Okay, and the router I will return packets to sender. So the sender will measure the time intervals between the transmission and the reply. So give you some idea how delays the networking you are currently using. Okay, for example, you are using Wi-Fi, wireless, and access to the different address. So I can quickly show you uh, a demo. So can you see the terminal I'm opening? Or you
No.
no?
No.
Okay, okay, let me reshare the terminal. Maybe only the terminal. Now it's fine, right?
Yeah, we can see it.
Okay, so I think the trace route, the program, right? So if you are using the Mac, you can easily use a brew install or or I mean, if you are using Linux, you can use a apt-get, right, to quickly install this software. And after you install, you can use the trace route to measure the delay, right? The networking, the internet delay you are currently using. So I just tested if I type google.com, right? So it will measure, send the 3 packets, and the packet will go through the router, right, one by one to the destination, Google's server IP, right, and then we'll return the packets back, and we will measure the delay. So you can see that the delay is pretty good, small here, right? So, and usually it will stable but sometimes it could increase. And if you send it to the internet, sometimes the delay would be high. But generally speaking, if you are in a good internet, the delay is kind of stable for the 3 packets. So maybe we can also try the other book. It looks like there is a packet loss. So star means that there is a packet loss, right? For some router. Uh, okay, but for the other router, it's fine. Okay, so there are more routers than we access the google.com. Okay, you can play with any IP address or DNS if you want. Okay, and if you want to know more detail how they implement that, you can just look into the documentation of that software. But that software will give you general idea about starting from your current device to the final destination, how many routers will go through, and what is the general delay, okay, for each router. Okay, so this is a quick demonstration. Let's go back to the slides. Okay, so the program's name is a trace route. You can easily download by yourself to test and to play. Okay, it will send the 3 packets, right, through the different routers. Okay, so as you just say that sometimes the packet could be lost, right? So we slightly mentioned that before. So why the packet could be lost, right? So why is the packet loss happen, right? So here is the case. As we mentioned, when you send a packet through through the router to the link, you will have a queue or buffer, right, to queue your packets, because sometimes a lot of packets arriving, they have to be waiting in the queue, but the queue has a capacity, right? So you can think about queue like a memory space, right? In CPU, you have a memory, right? But for the router, you also have some buffer or memory space, right? If the buffer cannot I mean, the capacity, right, exists, the capacity, right? The packet cannot be temporarily stored in the queue, then the packet will be lost. So the queue will deny to receive the packet, right? So then the packet will be lost, okay, and or dropped. The lost packet may be retransmitted by a previous node or previously router, right, by source and system. But sometimes they don't do that. It depends on the protocol, right, you implemented here. For example, we will talk about later, for example, for the reliable protocol, TCP, right? So if they detect there is some packet loss, they will request to resend the packet to this router again, or to this node again, right? So they have to make sure all the packet has been received successfully. But sometimes depends on different protocols, right? Sometimes unreliable protocol will not uh, request to receive that packet anymore, right? The packet will be lost, just lost. Okay, so this is a quick definition. We will talk about more after when we discuss about the protocol. We will give you an idea how we implement the protocol, right, to different packets, and let the router know there is some packet lost. But general idea here is that the packet could be lost if the queue has no space, right, or the capacity has is limited. Okay, another concept is throughput, right? I think we talk about the delay, right? We talk about the packet loss. We also know the bandwidth, right? So now what is throughput? Okay, so the throughput is the rate of bits number of bits divided by time unit, for example, second or hour, right? At which bits are being sent from sender to receiver. So if you know the total time from at the beginning of sending the data, sending the packet, and the um, end time of the receiving the packet, right? You can know how long the packet or the bit has been sending through the network, and then you can calculate the rate, number of bits divided by time, right, to calculate the throughput. And the throughput could be the instantaneous, I mean the instant, right? So this point you have the throughput, right, at a given time point. But also you can measure the throughput in a given time period. For example, you have you sending just as we demonstrated that, right? So we have sent the packet in our end, and we receive the packet when the packet is sent back from the Google to us again, right? So we can measure the time, and we can use the overall time and the number of packets or bits we sent to calculate the average throughput. Okay, so here below is the figure, right? So we send a packet through the server, right, back to your laptop or desktop. You can think about for the different links, right? There were different bandwidth and different throughputs, okay? And for example, here, for the first pipe, you can think about the link as a pipe, right? For the first pipe that can carry the fluid at a rate of RS bits per second. For the second pipe, you can carry about carry fluid at a rate of RC bits per second, right? For the different pipe, they have the different size, right? They have the different rates, right? That can carry the fluid, right? So for the different pipes, that means that you have the different capacity or bandwidth of the links, right? So here we are thinking about the overall throughput. If you have the different pipes, for example, here we have the first pipes RS and the second link or second pipe RC bits per second. If the first throughput is smaller than the second one, okay, what's the overall average end-to-end throughput? So because sometimes it's meaningless if you only measure one link, the throughput of one link, right? You want to consider about the end-to-end throughput. What is the end-to-end from the south to the destination, right? That's the end-to-end. So what about if RS is smaller than the RC? What's the overall throughput? Let me check the chat. Yeah, it's RS, right? So what about if RS larger than RC?
We're going to have a backup.
Yeah, it will be RC, right? Yes, correct. So this tells us what? This tells us how we can measure the overall average end-to-end throughput, right? It will be based on the smaller one or smallest one, right? If you have a different throughput along the links, right? So which one would be your bottleneck, right? So that means the link on end-to-end path that constrains the end-to-end throughput based on the limited by the lowest throughput, right, of the link, right? So that means sometimes if you connect to a very high throughput network, but if you are using Wi-Fi, right? So that doesn't make sense that the throughput would be that high because the bottleneck would be the last path, right, of the link, right? So you are using the Wi-Fi, right? So the bottleneck of the throughput could be limited by the final path, right, to your desktop or to your laptop, right? So if you want to have a very high end-to-end throughput, you have to make sure every piece of the link would have a high throughput on the path, right? Then you can make sure the overall throughput would be quite reasonable, quite good. Okay, so this is how we can think about the throughput, the local instant throughput with the overall throughput. Okay, so think about if you are using the different if you have different paths, okay, but the paths will share some same link in a certain space, right, or in a certain path, right? They share the some same uh, path together. Okay, so for example, here we have the 10 connections, right? We have a 10 desktop, we have 10 servers, okay? And each one will share, for example, the enterprise network in the campus, right? Or maybe the ATT link in this building, right? You have the sharing link. But generally speaking, the per link end-to-end throughput would be, we just got the idea, right? So it would be the minimal of RC, RS, and R divided by 10. So if we think about the R, that shared part could be evenly shared by the different connection or different paths, right? So it would be the end-to-end throughput per connection is minimum of the RCRS and R divided by 10, okay? But in practice, we know that the service provider or the enterprise network usually will have a high throughput of R, right? They will not let this part to be the bottleneck, right? So if, for example, we have thousands of 10,000s of the students on the campus, I mean, before the COVID time, right? So if you are using the network together, usually the campus network will not be the bottleneck, right? Generally speaking, if we set a good enterprise network, and in practice, usually the RC and RS will be the bottleneck. So when how you connect to the enterprise network, right? If you are using Wi-Fi, if you are using um, something else, right? And how the last path connect to the server, right? Would be the bottleneck. Okay. So this is some idea about the throughput. Okay. Yes, whichever one is smaller will be the bottleneck. So generally speaking, RS and RC will be the bottleneck in practice. Okay, so we have described the packet loss, delay, and throughput, right? These three concepts are very important, right? To generally speaking, it will give you the idea about the network performance, right? If you have a loss rate very high, that means a lot of packet will be lost. And if we are using the reliable protocol, that means you have to retransmit the packet. Then that's not good, right? You have to reduce something. The overhead will be large. But if the delay is large, even if there is no packet loss, but the queue is large, right? Or if you transmit the packet through the network, the propagation delay will be large. That means you also will have a large delay, right? And the last concept is throughput. Even if the delay will be small, but the throughput could be if the delay is small, yeah, but the throughput could be also small as well, right? So that means you transmit in a very low speed, right? Even if there is no delay, the delay is good, but throughput is low. So if we want to have a good networking, usually we want to have a less loss, less delay, and a high throughput, right? That means you have a high speed network. The high speed is a general concept, but what is a high speed, right? High speed has some different perspectives, right? Loss rate, delay, and the throughput rate. Okay, so I think we will have I mean, in your assignments, I mean, in the exams, how to calculate loss, delay, throughput, that would be basic question. Okay, so I don't think that's complicated because the equation is just a simple. Okay, but you have to understand how to calculate them. Okay, so any question So I think we have finished the performance part and the network core. Most of the important parts in this section we have already covered. So the next is some basic concept of network security, protocol layers, and some history. Okay, I will quickly cover that today and on Friday, and then we will finish the first chapter. Okay, before I go in next, any question?
I think maybe you mentioned this before, but the test will be open book, right?
I don't think I mentioned that before. I think based on, I think that there was a student asking, can we do the take home exam? That's the question. But for the open book, um, my idea is I don't think the question in the text would be a test would be too difficult. So I'm still thinking maybe we shouldn't do the open book test. Okay, but maybe we can allow a small cheat sheet, right? To if you so there is some formula is too complicated for you to remember, you can take a cheat sheet. But I don't hope you can do it during the exam. You just open the slides and open the book, just check how you do the assignments. So I don't want to do that. So what do you think?
So it just seems like if we're not going, unless you're going to get the exam proctored, there's not really any way to keep people from using the book. So it seems like the option
Yeah.
is either to have it be proctored or to have it be open slides and open book and everything, or to do a take home exam.
Yes, that's the challenge. I think during the COVID time in the department, a lot of faculty are discussing that. Some faculty still think about the open book is not good because some basic concept, right, to make sure you understand that you shouldn't do a open book. But just as you say, it's hard to protocol, right, the exam. So I will confirm that later before the exam. So I have to discuss with the other professor to see if it's okay, because previously some students choose this class, but they are not doing open book. But if we are doing for this semester, maybe the fairness is not good, right? But let me ask the other professors, what about their class? If they are also doing the open book, maybe we can also do that. But I know some professor would not want to do the open book, right? For some basic concepts, if you cannot remember the basic concepts and you need to do the open book, that may not be good for you. Okay, but thanks for the question. So I will confirm that. My initial idea is I don't want to do that, but if it's not easy to implement that and it's not easy for everyone to open the camera or something, uh, we can think about that open book. Okay.
Thank you.
Okay, so that's a question about the exam. Okay, but about the materials, if we don't have any question, let's continue. Okay, about the network security, or let me first check the chat. Okay, there's some discussion here. Okay, so I will make a final decision after I check with the other professor and other class. I want to make sure the whole department will have some same level of the teaching quality, right? So otherwise, maybe as the department will say that only the networking class has some easy tests and open book and the take home exam, right? So but I don't want to make you trouble. Okay, I want to make you as easy as possible, but at the same time, you can enjoy the class and learn the material. Okay, that's the basic principle. Okay, so for the network security, I think there are a lot of people doing the security today, right? So you know the cybersecurity is a very important focus of today's computer science, no matter the jobs or research, right? The cybersecurity is very important, and the AI is very important, right? A lot of people using AI for networking, right? So why the network security is important, right? So, and usually people, what are people are doing in the field or research of the network security, right? So first that there are some bad guys, right? So we use bad guys generally, that they want to attack the computer networks. They want to attack your servers, right? Even your local desktop, right? If they are connected to the network, right? Always there is some people want to do the bad things, okay? And then we first want to identify how they will attack the computer networks, right? What's their strategy? Okay, how they can do that. After we know how they can do that, and then we can know how we can defend that, right, against the attacks. Okay, so they are doing the bad things. We want to defend them to do that. Okay, and finally, how we can design architectures that are immune to attacks. So we don't want to have some people to guide or to defend 24/7, right? Every day, every hours. We want to design some high level or highly secured architectures of the networks to prevent these things. Okay, so why the internet would have some security problem? Okay, because at the beginning the internet was not originally designed security in mind. Okay, they are based on some principles that a good group of the mutually trusting users or people attached to the transparent network. They are trying to share the message. They are trying to share the information, right? They don't want to attack each other, right? They just want to have a better information sharing, right? Sending, receiving data. But later, so there's some bad guys appear, right? They're doing the bad thing. So the internet protocol designer at the beginning, right, playing catch up, they are not very secured, right? And the security consideration when weren't there for every layer, but now we have to consider the security for every layer, because we will talk about what is a layer in network. So now you know the structure of the network, right? So the network of networks is the internet, right? But later we will talk about what is the layer of the the networking, right? They have the different layers from application to the physical layer, right? I think everyone knows the application layer. Everyone knows the physical layer, right? The link, you have the Ethernet, that wire, right? That physical layer. But what's else, right? What is else between the application layer and the physical layer, right? So we have to design security secured layer for all the layers. Okay, so that's the network security. And what is a bad guy, right? So they are not necessary to be people, but usually the program or more malware with are developed by the people, right? But after they develop the bad thing, they can just send or put the malware to your host, right? So there are different malware, right? So for example, we have the virus, we have the worm, right? So for virus and the worm, so I think most of you should know something, or I mean, at least hear about that, right? So if your computer will have some virus, then you need to have some antivirus software to clean that, right? But if your computer have some worm, you also need to do some checking or examining and to clean the worm, right? So what is a virus and what is a worm, right? So for the virus, it's generally speaking, it's a self-replicating infection by receiving or executing the object. So for example, people will send the virus in a email attachment. If you click the attachment, right, usually you will click the attachment if you think about the sender is trusted, right? So you will open the email attachment, then the virus would be executed, okay? And for the worm, it's a self-replicating infection by passively receiving objects that get itself executed. Okay, maybe from the wording it's a little bit confusing, but I can do a quick clarification. So the primary difference between the virus and the worm is that the virus must be triggered by the activation of the host. As I mentioned, if you open the attachment, right, email attachment, then you trigger the virus, right? And while the worms are standing alone, malicious programs that can self-replicate and propagate independently as soon as they have breached the system. Okay, so that's similar, but the principle is that the virus you have to click, you have to trigger, but the worm can self-propagation, self-replication, right, independently as soon as they inject it to the host. Okay, so there is some other bad guys, for example, spyware, right? They can record keystrokes, website visited, upload information to a collection site. Okay, so that means they record everything you are doing, right? For example, they can record your password, right? So if you are access your online banking account, they can access your password, they can access the web page you are visiting, right, to get your privacy, and they can upload the information to the connection site, right? So that's why I think maybe every year or with several years there is a big um, I mean, news happening, right? So some uh, website or some company, they leak their customer or users information, right? And a lot of passwords and private information were leaking, right? So um, that's why it's very important to protect, right? So because if your password is you know collected by the bad guys, they can just transfer your money, right? They can just do a lot of bad things here. So, and final bad guy is deny of the DDoS. So we will talk about what is the denial of the service, DOS. But generally speaking, that they will infect the host uh, by enrolling it into the botnet used for spam or distributed denial of the service attacks. Okay, they just enroll you into other networks, right? And that network will send you a lot of spam and will make your service be denied. Okay, so generally speaking, so these are the malware you usually can see in the network. Let me check the chat. Owners are also used for Bitcoin mining and creating fake social media accounts. Yes, yes, that's a good note. Yeah, so the botnet is a we will talk about some bonus things in this slide, I believe, right? Yes. So they can make you receive the spam. They can make you to the DDoS, and they can also involve you to some other bad service. So, but here, let's use a denial of the service like the example. Okay. So the denial of the service is a very commonly seen case. So if you check DOS, you can see that maybe every several years, there is a large scale DOS things happen to the different DNS server or some companies, right? So the attackers will make the resources, for example, the server bandwidth available to legitimate the traffic by overwhelming the resource with bogus traffic. So generally speaking, that they will infected into the different host and make the service or the network traffic to be denied by the server, right? So they will make your normal access to be very, I mean, frequently, more frequently, right? Because sometimes you only need to access the server one time, but if you were injecting to the different hosts, so they will keep and frequently accessing the target, and the target network bandwidth and response will be very delayed, or maybe they just deny your your request of the access, right? So first step is they select the target and they break into the host around the network, right, to the botnet, and they will send the packet to target from the compromised host, right? Just as I mentioned, so generally speaking, you just need to access the server maybe every 10 or every 20 seconds, but if they inject into your host, they will keep frequently access and make the server to be deny your access request, okay? So this is one example of the DOS. Okay, and there is some other packet interception. For example, this is a packet sniffing. So they will broadcast your packet through the Ethernet and wireless to the I think they will record and read all the packets, right? They will record and read every packet you send. For example, here, if we want to send the packet from B to the destination A, right? So if you have another, so here is a C, right? So they can sniffing every packet you send or record and read every packet you send from B to A, right? In the link, right? Sometimes you don't know that maybe some people just put another malicious router or something between your normal path, right? And that device can record everything you send between your destination and the source, okay? So there is some software, so Wireshark, that software is a free packet sniffing software. So you can download and take a look at it. Okay. Previously, I think we have some lab to test that, but now because we don't have lab, so you can do it by yourself. Okay. Yeah, this is a good question. So what about the Prometheus network interface, right? So here is a maybe a quick example. So we can talk about details later, but here is a quick example. So sometimes if you want to pass the packets to the destination or to the other routings, right? So if you can attack the router or routing algorithm, right? So they can just send the packet to both the next routers, right? But one of the router could be the malicious routers, right? So they can affect your router and change your routing algorithms, right? Or maybe change the packet, the destination address, and they can record the packet you send through the networks. Okay, so here's, I think it's just a quick explanation, but how we can implement that, I think is a more deep question. So if you're interested, I can share you some document and or some paper you can read about how you can implement that, the interface change. Okay. So another thing is the fake identity. So here is the IP spoofing. So you send the packet with a false source address, right? So you will change the destination. Not like before you record or just save every packet, but here you just send the packet to the false destination. I think this is easy to understand, right? Usually you need to send the packet from B to A, but now you just change the destination address and send to C, right? So we have lots of the security problem or thought we can talk about later in chapter 8. We can go into the detail about how we can implement this snooping and the sniffing things here, okay? Okay, so I think that's a quick introduction of the security. Um, we still have 10 minutes. Let me try to give you some idea about the protocol layers and the service model so that we can finish this chapter next class. Okay, so what is the protocol layers and what is the reference models? Okay, so think about some idea about that if you have the very complex networks with many different pieces, right? From host, routers, links, application, protocols, hardware, software, right? You have a lot of things here. So we don't organize those piece of the those pieces into some organization. Then the network will be very complicated and unorganized, right? So is there any um, I mean, pause, is there any possibility to organize the structure of networks to the different layers? And what's the benefit if we organize them into the different layers, right? Because now everything looks a little bit messy, right? We have to design a more clear organization to manage this host, router, links, application, protocol things, right? So let's think about some real, the real world situation. For example, if you are organized travel, right? So you first need to buy the ticket, and then you need to do the check your package in the baggage area, right? And then you go to the gates, you load, and then the flight take off and the runway, and the flight will route in the different areas or different regions, right? And after the flight routing, then it goes to the destination and the runway landing and the gate to unload, and you have to get your baggage. And then finally, if you have any complaint about your ticket or about your travel, you just call the customer service, right? So that means we have the user airline travel as an example. So you have a series of steps that involving the different service, right? So if we think about this service or this different steps as a different layers, right? You can see that we have the ticket layer, we have the baggage layer, we have the gates layer, we have the runway takeoff or landing layer, and finally we have the airport routing layer, right? When the air flight is flying and you have to route the flight into from different region to different areas, right? So if we think about the flight air travel as an organization, you will have the different layers, and each layer implements a service, right? So you can see here, so the different layer will have the different services, right? They are responsible for their own layer service, right? Next slide, we'll talk about what is the benefit, but here you can think, just quickly think about that. Different layer or different service in the different layer, they are only responsible for their own service, right? So they are transparent to each other. And even if one layer is failed, you don't need to replace the whole organization, right? You just fix the service in that layer, right? So that's an easy organization to maintain and to provide a good service, right? For example, if your ticket service is failed, right? No one is responding your tickets, or even the ticket price is not good, then you can complain only to the ticket. They will not affect the other service, the baggage or gates or runway, takeoff, landing, or the routing, right? Flight routing, right? So that means if we divide the service into more organized layers, then they would have some benefits here, right? So generally speaking, why we are doing the layering, okay? So if we are dealing with a very complex system, this is not only about computer system or networking system, right? It can be a lot of system, right? In the world, okay? So if we divide or deal with a complex system based on the layering strategy, right? So the layering could help us to modularize the different services, right? And as I mentioned, so this modularization could help you to ease the maintenance and updating the system, right? So if some layers is failed, right, it doesn't affect the other layers. And if we change layer service implementation, it's transparent to rest of the system, right? Everyone seems every layer it seems in the system to be independent to each other, although they are connected to each other. But if we want to update, if we want to implement a new service, that's fine, okay? You can almost modularize every service or every layer, okay? And layering considered harmful. So I think there is some overhead if you do a layering, right? Transfer between the different layering. But generally speaking, I think layering is a good strategy for very complicated system. So is there any other layering in the complex system? So as I mentioned, it's not necessary for the computer system, right? But in computer system or operating system, we have layers, right? So I think most of you here should learn the operating system, right? So what layer, which layer you know in the operating system or computer system? So here we're talking about networking, right? But for the computer system, we also have the different layers, right? Different layers for different service. Okay.
I mean, I guess there's kernel space and user space are like kind of layers.
Mm-hmm. Yes, good. Yeah, good point. So here, yes, you're right. So we have the user layers, right? We have the application. After users, we have the application, right? And then we have the different library routines. We have the system calls. We have the system, right, calls layer. We have the operating system. We have the hardware component, right? So yes, it's similar to the computer system. We have the different layers. And the good thing is that if the hardware is broken, if you want to update the hardware, the beyond the operating system to user layer, you don't need to replace, right? If you want to update CPU, you just install new drivers or something. The other component application will not be affected, right? So that's the benefit for the layering. Okay, so I think that this could be the this should be the last slide for this for today's lecture. So let's just quickly look at what is a different layer or different service in the internet protocol stack. Okay, so as I mentioned, everyone knows the application layer, everyone knows the physical layer, right? But what is in between? We have the transport layer, we have the network layer, we also have the link layer. So let's quickly go into one by one. So for application layer is supporting the network application. For example, the SMTP, HTTP, right? IMAP is for the email, right? The SMTP, also for the email, HTTP for the web service, right? Website. And after that, we have the transport, right? Process to process data transfer. For example, TCP, UDP. We will talk about these protocols later, right? Very detailedly, because these two protocols are very important. Okay, and after that we have the network. We have the IP routing protocols, right? After you have the TCP, you have to send the data packets to the different IP, right? You will have the network layer, and after that is a link, right? The link layer. So we have the Ethernet, we have the Wi-Fi, we have the triple P, right? We have the different link. That's a data transfer between the neighboring network elements. Finally, we will have the physical layer. It's a bit on the wire, okay? So similar to the airport or not airport, but the air travel, right? That case, we have the different layers here, okay, for the internet protocol. Okay, I think that's it for today. For next lecture, we will finish all the layering things for the protocol, and we'll talk about the internet history, and we will finish the this chapter. Okay, and go to the next chapter. So I think I noticed there is a good comment from Brianna. So here is his or her thought. I would prefer to take home or open time window to take the test. protocol tests are difficult to set up on the schedule, plus they cost like 40 per test, and now everyone is taking classes and working from home is difficult. Okay, thanks for your suggestion. I think this is a very worth discussing suggestion, and kind of agree with your point, I will give you a very final confirmed decision for the exam after I check with the department chair, because previously he mentioned that some class need to do the test even with the protocoling with some expense, but because this is senior course, maybe we can just ignore that. But hopefully I can get back to you after the long weekend. Okay, I will give everyone a confirmed information about how we conduct the test. Okay. Okay, that's good. Okay, thank you. Okay, if you don't have any question, let's end today, and hopefully, yeah, see you next lecture. Okay. Okay, thank you. Have a good day.